excess phase reaction, this is a reaction given, A plus 2B is converted to AB2, and Kc is given here, temperature 200 degrees centigrade, and question is when 2 moles of B, so B is 2 moles is mixed with 1 mole of A, this is 2 mole, this is 1 mole, and what is the total process pressure is required to convert 60% of A. Now, this is the 1 mole, so when you take the 60% A in AB2, so in that case what is the total pressure we require? We have to find the total pressure which will convert 60% of A into AB2. So we have to write the reaction first. So A is given here, initial mole, so A, and this is A, and this is reacting with the 2B is giving you your AB2. This is our reactions. Then initial mole is given how much? So initial mole is given, this is your 1 mole, and this is your 2 mole, and this will be your 0 mole. Now at equilibrium, so what will be the moles? So if you take the equilibrium, so in this case, so what will be the moles? So moles will be, so it will be reduced by x mole. This will be 2 minus, we can say 2x, and definitely this is your 1 molecule, so 1 mole, this is your x mole. So what will be the total moles at equilibrium? So total moles will be at equilibrium will be total moles at equilibrium will be how much? So x is cancelled, so we can say 1 minus x plus 2 minus 2x and plus x. So on solving, you will get here, this is your 2 plus 1, 3 minus x, these are the total moles. Now we will use the apply of Kp. So when you apply Kp, so Kp is equal to moles of AB2. We know the formula, this is the formula, and moles of A and into moles of B. See, this is the power square, so we can write a power, and this is the total pressure, and divide by summation of number of moles whole. This is the delta, and this is the formula. If you apply this one, so we can write Kp will be equal to moles of AB is x. This will be your A is 1 minus x, so this is 1 minus x, and NB will be your 2 minus 2x, and this is your again square, and multiplied by a pressure. Total pressure is given, and the total moles is 3 minus, so this is your this is how much? So this is cancelled, this will be your 2x, please make it correction, so 3 minus 2x, and this is your whole. So delta n is your 1 minus 3, so 1 minus, so if you solve it, 1 minus 3, so it becomes your minus 2. So on solving, this is minus 2. So if you solve it, so if you solve this one equations, so you will get here equations. So this is your, so again a pressure is, we have to find it out. So if you solve it, this becomes your x, and this is becomes your, so this becomes your 3 minus 2x whole square, because this is minus 2, so this will goes up, and remaining will be your 1 minus x multiplied by 2 minus 2x, this is whole square, p will goes down as a square. So again if you solve it, so again you will get here, this is equal to, you know very well, that is Kp is equal to Kc RT delta n. This already we know the formula. So in this case we'll get here just Kp equal Kc RT delta n. So we know the Kc is given here at 0.3475, so we can write here Kc 0.3475 and multiply by RT value is, again it is given RT value, that is value is 0.0821 and multiplied by 473 Kelvin, and this is your power is given here minus 2. This power is given already here, the minus 2 here. So if you solve it, on solving you will get here this Kp value. So this value is your 2.3 into 10 to the power minus 4. This is a Kp value. Now from this value, and already we know the Kp value, so if you substitute value here in this Kp value, So on substituting, so we know the Kp, this is, so we have to find out the x value. So if you substitute the value here, so what we'll get? So now Kp is 2.3 into 10 to the power, so 10 to the power minus 4, and x they have given 60%. If you remember, this is 60% given, so 60% is 0.6. This becomes 3 minus 6 into 2, 1.2 whole square, and divide by 1 minus x, 1 minus this is 0.6, this will be your 2 minus, this will be your 0.6 into 1.2, and multiplied by p square. We have to find p square. Now we can find p square. So if you solve it, on solving, p will be equal to 181.5 atm. I hope you have understood how to solve this problem. So first we have found out the Kp equation. After Kp equation, from the second question was Kc, this one. After solving, we got the Kp, and Kp value is substituted over here. So then we got it here. X is also given. So x, after solving x, we'll got the p, and this is our answer. So answer is, for this equation is 181.5 pressure atmosphere for this question. A plus B is giving C, and the equilibrium concentration of A and B at a temperature of 15 mole per liter. So A and B is 15 mole per liter, and when you double the volume, so when the container volume is double, so the reaction has the equilibrium concentration of A is 10 mole per liter after doubling the volume. You have to find out the Kc and concentration of C, original concentration. So on doubling the volume, Kc will not change. This we know very well. So A plus B is giving you concentration C, and if you see the at equilibrium concentration means E1, first equilibrium concentration is given 15 mole per liter. So right here 15 mole, this 15 mole, and this concentration something will be there. So let us write A mole. This is per liter is there. Now when you double the volume, so when volume is double, so when you becomes volume is double, so volume is 2 times. In that case, we have second equilibrium concentration. So this will be, and on doubling the volume, what will happens? The reaction will go which side where the concentration is more. So it will go backward direction. The reaction will go reverse on doubling the volume. The reaction will reverse on doubling the volume. So this is 15 by 2. Previously 1 liter. Now on doubling volume, you will get some x for A, and this will give you get 15 by 2 plus x. Definitely concentration of A will decrease by A by 2. This is concentration of minus x. It will decrease. Now for this one, what was the Kc? So Kc was your A divided by 15 square. Now in this case, what was the Kc? Kc will remain same. So in this case again, Kc will be, you can say, equal to, for second case we are seeing what is the Kc. So Kc will be equal to your, we can write here. So this will be your same thing. So we can write on solving same, that is A by 2 minus x, and this will be your 15 by 2 plus x whole square. And one more thing, they have given the 10 mole concentration for this second equilibrium concentration. So we know again, that is, let us write this side, 15 by 2 plus x is equal to 10. So from here x is equal to, if you solve it, it is something 5 by 2. So 10 minus 15 by 2 will get this value. Now we can substitute the x value over here. So if you substitute it, this value, so you will get here. So this is equal to, so Kc will be equal to your, this is A by 2 and minus 5 by 2, and this will be your 15 by 2 plus, this plus is there, 5 by 2 whole square, that is equal to Kc. So from here A by 2 is given, and this is given here, and 1 Kc is already given, A by 15 square. So this is already given here, A by 15 whole square. So from this equation and this equation, if you solve it, you will get A value is 45 molarity. If you solve it, already I have calculated. So this is the wave calculation. And what is the value of Kc? So if you want to solve Kc value, so Kc is equal to A by 15 square whole square, and 50 we know that is equal to A is your 45 divided by 15 whole square, and on solving you will get this value as a 0.2 molarity. So this is our consideration of this equation. So answer is your 0.2 molarity for this question. That is the original concentration of the solution, and this case is given here. Original C is this is C is your 45 molarity. Already we have found this answer.